Welcome everybody to another video. Today we're going to be looking at impulse. So, the velocity of an object, and hence its momentum, is only changed when a force is applied. You can see that in the first line. And we talk about it in terms of how long that force lasts. So the longer the force lasts, time increasing, the greater the velocity and momentum change. Increased change in velocity, in brackets, change in momentum. We could also talk about the fact that the larger the force, the greater the velocity and momentum change. So same thing, a larger force is equal to a larger change in velocity and thus momentum. The product of the force and the time taken for it to act is called impulse. So when you talk about impulse, well, we're actually talking about the effect of a force and the amount of time it's taken for that force to apply to an object, okay? And what happens to that object, that's the impulse. So what we have here is our force is equal to change in momentum divided by change in time. But as we know, force is actually equal to impulse is actually equal to force times change in time, which is then obviously equal to change in momentum because they cancel out. And so we can rearrange that formula to the one seen on the right there, which is force times by change in time is equal to change in momentum, and these are all equal to impulse. Cool. So, some definition and units. Impulse is the product of an unbalanced force and the time it lasts on an object. Impulse equals the momentum change of an object which is experiencing that force. Okay, that is a critical understanding here. And if you look at the units, force is done in newtons, time is done in seconds. You can rearrange that very easily into newtons, which is what we have for our momentum. So just swapping the way they're multiplied by, you can see that our units is exactly the same. So when you talk about impulse, we're really commonly talking about a change in momentum, or what was the force and time combination to create that change in momentum. That's the important bit. So an example here. A cricketer catches a ball of mass 400 grams in 0.1 seconds, which hurts his hand. His mentor teaches him to follow its path when catching it. You know, when they grab the ball up high with their hands outstretched and then bring their hands close to themselves in the same direction of the ball that's traveling, okay, increasing the amount of time it takes him to catch it. So the next time he does that, it takes 0.5 seconds. What was the difference in forces? Okay, what was the change in the force involved? So in both cases, the ball was moving at 440 meters a second. So let's have a look. Our velocity initial is equal to 40 meters a second minus 1. Our mass is equal to 0.4 kilograms in both situations. Our change in velocity, though, is going to be equal, you should be able to see that here, is equal to 0 meters a second minus 1. It's come to rest, he's caught it. Now the time for the first situation is equal to 0.1 seconds, and the time in the second situation, so time 2, is equal to 0.5 seconds. So let's use our formula here. We have a mass and velocity, and we can have a look at this using our 4F method. We've got our facts. Let's go for our formulas now. Let's calculate out the change in momentum, because the change in momentum in both these situations is exactly the same. Our initial velocity and our final velocity are the same, and so is our mass, so our change in momentum is going to be the same. So you should remember that change in momentum is equal to velocity mass take velocity initial times by mass, which in this situation is going to be 0 times by 0.4, which cancels out because it's times by 0. Take 40, times by 0.4. So our change in momentum is equal to 15. Now, these are in newtons, of course. Let's look at our new formula. Our new formula that we've just had a look at is our impulse formula, which states that impulse, which is equal to change in momentum, which is equal to force times by change in time, we can now use. So we're going to go and put this into the next section here. So for the scenario 1, we'll go with T1 here. Our force is equal to delta T equals delta P. So we're going to go to the find it section now of our 4F method. I should write. And we're going to convert this. We want to know what the force is because we know what the time is. So force is equal to, in this situation, our delta P over delta T, which in this case is going to be equal to 16 divided by 0.1. Okay? 16 divided by 0.1 equal to 160 newtons. Okay? Because we've cancelled out the seconds here. So the force on poor Joe Blogg's hands here for the first situation is 160 newtons, quite a lot. Let's try this again, but with our second time. So same process, I'm going to abbreviate this down to force is equal to delta P over delta T, which in this situation again is our same 16 newtons, because that's the same change in momentum, but this time it's over a time of 5 times as much, 0.5. Okay, so that is going to be equal to 32 newtons. And so in terms of the actual action force hitting the poor lad's or man's, woman's, whoever's hand is very different, of course. One has an impact force of 160 newtons, the other of 32. So by increasing the amount of time it takes for that change in momentum to occur, we reduce, in this situation, the amount of force that's directly impacting it. And this is the principle behind everything from how we catch cricket balls, to how cannons and tennis rackets work, to how we have crumple zones in cars, why airbags are a thing. All of these situations are all relying on impulse, right? And the explicit understanding of impulse. So, hopefully you've learned from this video a little bit about how to describe impulse. You've had a look at its definition and its units, and we've had a look at how to rearrange formulas to be able to get to it. But fundamentally, please remember that impulse is just the change in momentum, okay? And it can be described as the amount of force over the amount of time taken for something to occur is also equal to impulse. Okay, thanks for listening. I look forward to seeing you in class.